This is just a bit of a video on, it's going to be a bit of an ongoing series over the course of the next couple of months, or at least between now and probably sometime in late December. These are some fake 74 LS04 chips that were causing some problems in some labs. Build quality in these is pretty abysmal. This is what I was able to do with some side cutters in about a minute. I mean, the epoxy just absolutely disintegrates, and what isn't really apparent on this is, although you can see that the die, you can see that it was all centered by a good 20 or 30 mils on its mounting plate, which, considering that these things are machine wire bonded, generally not a very good thing to have them misaligned like that, especially given that these are supposedly about 30 years old. Vision systems weren't really what they're capable of now. They're just machine vision and whatnot. And but anyways, this chip originally had a big chunk broken out of it, and I was able to, over the course of about a minute with some side cutters, to just split it open like this, and the bits of the lead frame were so skewed as to almost be touching. And again, of course, and I've got some heavy-duty epoxy stripper, so I'm going to see about getting or dissolving the epoxy off of that die to see what's actually on the die. And I have 2 more of them, and then I have this. You probably notice a problem. There's a device marked DM74LS04, although the ink or paint is wearing off, which is not a good sign with legit devices. But it's got 8 pins and another 8 pins, so it's a 16-pin chip marked DM74LS04. There is no such thing. Every single variant of the 7404, whether it's, and I just have a handful of examples here. There's like a 74F14. This is a Schmidt trigger version, and it's a fast TTL variant. It's 74HC05. The 05 is just same chip. It's just got a open collector output instead of totem pole. And I've got a 5404, which is a mil-spec variant. Basically, wider operating potential range and very high range of temperatures on which the thing will operate properly. So yeah. And as you can see, they all have 14 pins. Now, there is one thing, is that the size of the epoxy cap looks to be exactly the same on the two, although that isn't necessarily screaming fakery, because this is a genuine 16-pin part. This is an XR2206 monolithic function generator IC, just because it's the first thing that I happened to grab out of my lab kit. And you can see that the epoxy is the same size as this 7404 thing, and it does have the little odd narrower legs on the end of the lead frame like this does, but yeah. Now, one thing that I suspect is the case with these is that these are probably, judging by the ages of some of the other devices in this particular kit that these were supplied with, I'm suspecting that these are probably Soviet communist fakes. These really kind of predate the Chinese communist fakes that are very common nowadays. But these are probably from either a fab in Russia or one of the now former Soviet republics. And I suspect that just based on that star, which is a commonly used thing that the commies would do on their industrial standards. Like, for example, these 2 panel meters, which are Czechoslovak made Metra Blansko ones. Made in, this particular one is one of these 1969, and this one is 1971 or 1972, I think. So As you can see that one of the markings there is a That star with a 2 in it. And again, this one, the finish, and it's gone a bit crinkly with age. So yeah. So one of the things I'm going to be experimenting with is trying to decap this one. This particular, or decap these. This particular one, what I'd like to do, if at all possible, is preserve the front of it, like the writing, although that's probably not going to be possible because this one was in my pocket for about a week, or only a few weeks, and that would just completely abraded off all the markings on the IC. And so that's where the pins are kind of dead bugged in like that, but yeah. So there's going to be some videos on this, and that's also why I ordered this end mill. This was kind of a lot of stuff that came in since I left from Granger. Got these on clearance. I didn't know there were roughing mills at the time, but considering that I only got this for a couple bucks, don't really care. Although it might be a bit big, because really what I wanted to do is machine out a pocket. Except the thing is that the epoxy stripper that I've got is a paste, which might help hold it in. So what I'm going to try with this one is strip it away, the epoxy on the back, so I can peel back the mounting plate and then dissolve out the dye while leaving the writing intact, but that's probably not going to be possible. And another thing that I know that is of note is that this device and this one that I cut open have a score on the bottom, which is indicative that they're probably fakes. That looks like a mark that would be made, or I'm guessing that'd be a mark that would be made to indicate that these were failed chips. And then they just happen to be badged anyway by some illicit third-party supplier when they should have been scrapped, but yeah. That's going to be some more videos on these in the coming days. This is a further bit of work in trying to reverse engineer, just find out what exactly the dye in one of these fake 74LS04s is. Just have some of this, it's a paste epoxy stripper, it's a crown tough strip, semi-paste stuff. It's is having an effect. The paste is turning that dark gray blackish color, so it is dissolving some stuff. I need to help it along with some scraping. So yeah, and then see about getting a microscope and seeing what is actually on the dye. Yes, I know fuming nitric acid would be a better solution to this, but it's looking in Sigma Aldrich. It starts at about $100 a quart, and I'm poor and I don't need anywhere near that much. I need maybe like half a cubic inch or so. Edifying, isn't this? This is a bit of a WTF moment in the reverse engineering of one of these fake chips. I've cut it in roughly about half. I mean, I'm chipping down to the bit where the die mounting plate would be, and there isn't one. As far as I can tell, it's just pairs of lead-in wires. There's no typical structure of the form you'd expect to find in one of these things. It would be, what I expect to find is some kind of a structure roughly like this, where you have a die mounting plate, and there would be little spray things sticking out the end there. That's just used for centering the centering the lead frame thing, or the support plate that the semiconductor die is mounted on, which is the little square thing. And then that would be just wire bonded out to a series of pads. And I'm not seeing that in the chip. What I'm seeing is just structures where you have things like just like this bit, where you just have pairs of things. I can't really find any dies. Problem is I don't have any fuming nitric acid, so I couldn't just dissolve all the epoxy off and just leave the metal, although granted that would turn the metal into all kinds of nastiness, nitrogen oxide fumes, and what would mean not having a proper vent hood and all, but very interesting in a not good way. I mean, I cracked open one and that did have a die in it, but internal structure was also a bit different. Yes. Interesting in an interesting way. And you can see from the end there it's just wire in, and I'm at the bit where in one of the ones that I cut open there was a typical lead frame structure, a bad one, but the chips are proving to be a little bit on the WTF side. And another thing that I just noticed about this one chip that doesn't appear to have a lead frame is that there's no little metal pip on the end that you get from little bits of metal attached to the die mounting plate that stick out the end. Now some, like this weird 16-pin one, have it. And like that one. I mean, that's a fairly common feature, just as an artifact of the manufacturing process, because there's no real way to embed that within the epoxy unless you apply a second coat or something. Because the way these devices are manufactured is that the whole lead frame is manufactured as a whole spread out thing. Die is bonded. I get really bad allergies. But the die is going to be bonded to that. It's wire bonded out to the various connections. Then the epoxy is coated and the whole thing's bent down and the excess bits are clipped off. But this particular chip doesn't have any of those features. It's like it's just a lead frame in a lead frame in epoxy, but there's no silicone in it, which explains why the bloody thing wasn't working. And then there's other ones like this. It'd be interesting to see what's inside that one. But yeah, that's a bit of a WTF. I mean, a legitimate lead frame would be something like that for something like a diode network, but because then there wouldn't be the central die mounting plate. I mean, you just mount each die in each pair. But don't exactly know how those are manufactured, but very interesting. And here's just an example of the of how that this epoxy stripper just takes that writing right off. As it just disappears. Scrape it off. And legit, I see markings. The paint would not really be susceptible to things like this or things like rubbing alcohol, which, methanol, that is, well, rubbing alcohol is generally isopropyl, but methanol is another one of those alcohols if you, it's really poisonous. So yeah, but yeah, and this one, even on the bottom, you can see a bit of that lead frame structure. You can see how these ones are bending in. So this one probably does have silicon in it. Yeah. Interesting. This is just the latest in my various attempts to get into this fake chip. It wasn't very effective. Just blobbing the epoxy stripper on it. So what I'm doing is I'm just using a roughing end mill and just a battery drill. Yes, I know that's how you're supposed to use these things. I don't have a proper milling machine or a cross-slide vise, otherwise I'd use one of my drill presses. But yeah. And yes, I know, risk, blah blah blah, brushless or brushed motor, possible flammable fumes. I'm checking, performing small tests. Yes, blah 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 blah. Don't try at home. Blah 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 blah.